Hi, I'm Sanjay Nagchowdhury, Development Lead for the IBM App Connect Enterprise product. In this video, I will demonstrate the new capability added in 12.0.7 which supports OpenTelemetry trace for an integration server, so that you can observe transactions in your integration solution using tools like IBM Instana. I will show how it can be configured in the integration runtime of an ACE operator in a Red Hat OpenShift cluster, and then view spans in IBM Instana. This feature enables you to track data as it passes between multiple applications. OpenTelemetry is an incubating cloud-native computing foundation project which provides an open-source framework for tracking and correlating data as it passes between disparate applications. Capability has been added in IBM App Connect Enterprise, which allows you to configure OpenTelemetry trace for all message flows in an integration server and emit span data to an OpenTelemetry collector. When OpenTelemetry is enabled for an integration server, spans are created for all message flow nodes that support OpenTelemetry. This new feature makes it easy to use tools such as IBM Instana or Jaeger to show trace data as it flows across multiple protocols and applications. IBM Instana is an observability platform. It lets you see lots of different kinds of data, which allows you to observe how your software is behaving. The data can be used for monitoring CPU, view memory usage, and for tracing. IBM Instana conforms to the OpenTelemetry standard, which allows you to track data as it passes from one application to another. In my demo, I will be using App Connect Enterprise message flows and IBM MQ. Instana agents are used to collect data from IBM App Connect Enterprise and MQ. They forward the data to the Instana backend. I'm using IBM Instana that has been installed in the IBM public cloud. Previously, trace events were omitted through user exits of nodes in IBM App Connect Enterprise. Users were able to invoke user exit callbacks to add instrumentation. Now, in ACE 12.0.7, we are omitting those trace events in the nodes themselves so that user exits no longer need to be configured by the user. The result of this is that we now have much better performance when using the OpenTelemetry standard. All activity in a single transaction is known as a trace. A trace may consist of many spans. A span is a unit of work which occurs while an application is running. A span can create child spans which can overlap in time, for example when a HTTP client invokes a server. The ACE nodes which currently support emitting the trace events are MQ, HTTP, REST, Callable Flow, and SOAP nodes. For this demo, I will be using the Coordinated Request Reply tutorial, which uses both HTTP and MQ transports. The sample has a request flow, which receives a request over HTTP and sends back replies in a separate reply flow. In the middle is a flow which is simulating a backend application. The request flow uses a subflow to store the reply identifier so that the HTTP reply can be sent back to the correct client. The reply identifier is stored on a queue called store.queue. The queue is used later by a subflow when a reply is sent back. The request flow puts a message to a separate queue called backend.queue. The backend flow gets the message from the backend.queue and does some computation, and then puts a message to another queue called backend.reply. A reply flow gets the message from a backend.reply queue and looks up the reply identifier using a subflow, and then sends the message back using the HTTP reply node. So I'm showing the App Connect Enterprise toolkit. This is using version 12.0.7. I'm going to import a tutorial. So the tutorial I'm going to import is the Coordinated Request Reply tutorial, which I just gave an overview of. So this uses a combination of HTTP and MQ transports. So this is the request flow which receives the HTTP request. As I said before, it has a subflow where it stores the reply identifier. it puts a message to a queue called backend.queue. We have a flow called backend application flow, which simulates a backend. It takes the message from the backend queue, does some computation, puts a reply on a reply queue, which is read by a reply flow. So the reply queue is backend.reply. This is read by reply flow. The HTTP reply identifier is retrieved from the store queue, and then that is used to send the HTTP reply. So I'm going to use this tutorial, and I'm going to then show spans that can be observed using IBM Instana. I need to use IBM MQ. I'll be using the ACE operator and the MQ operator on Red Hat OpenShift container platform. I have a queue manager already defined. I just need to get details from there so that I can put those details in a policy project. So let's bring up the Red Hat OpenShift container platform. And in here, I have a project called ACE. And I already have an IBM App Connect operator, an IBM MQ operator, and an Instana agent operator already installed. In IBM MQ, I'm going to show the dashboard. So I'll just open it in a new tab here. And here I have a queue manager called Quick Start, which is already created. It already has the 3 queues defined: backend.queue, backend.reply, and store.queue. It has a channel that's going to be used, system.auto.servercon. And I'm going to be using port 1414 as the listener. So I'm going to use this information in a policy, which I will create in the toolkit. So I'll just return back to the toolkit. And in here, I'm going to create a policy project. I'll call it MQ. And in the MQ policy project, I'll create a new policy, which I'll also call MQ. So the policy is going to be of type MQ endpoint. So for queue manager, name is Quick Start. The host name I can retrieve from the Red Hat OpenShift container platform. I can open up networking and click on services, select ACE MQ, IBM MQ. And on the right hand side here, I can see the host name. So this is the host name to use for the queue manager. And I'll be using port 1414, and the channel name will be system.auto.svrcon. So I can save this policy, and now I can add this policy project to the bar file. So the bar file is already provided by the tutorial. I'm just going to update the bar file to add the policy project. So I've selected the MQ policy project. I'll click on build and save. And now the policy project is in the bar file. So now I'm going to deploy this bar file to an integration runtime in IBM App Connect using the IBM App Connect container running on Red Hat OpenShift container platform. So I'll open up the dashboard for IBM App Connect. So I'll open it in a new tab here. So I don't have any integration runtime at the moment, so I'm going to create a brand new one and deploy the bar file. I'll select Quick Start Integration. I'll drag and drop the bar file that I just built. Click Next. I need to specify a remote default queue manager so that the Quick Start queue manager can be used. So to do that, I'll create a configuration and specify a configuration in the server conf YAML for the integration server to use. I'll give it the name of default QM, and I'll specify the property to be used in the server conf YAML, which is a setting for remote default queue manager. And here I'm specifying the policy project MQ and the policy MQ. So I'll click on create. So the configuration has been created. I'll click Next. And finally, in the Properties section, I'm going to select OpenTelemetry tracing to be enabled. And now I can click Create. And now the integration runtime is being created. I can check the status of the integration server by going to Workloads, then Pods. And I can see if this pod has just been started, it's running. If I click on it and I'll select Logs, I can see the output of the console. And here I can see the server has started and the flow has been deployed. If I refresh the dashboard for IBM App Connect, I can see that the integration runtime is now ready. If I select it, I can see the application is deployed. If I select the application, I can see the three flows, the request flow, the backend flow, and the reply flow. And for this integration runtime, I can see it's using this default QM configuration, and I can see the bar file that it's using as well. So the flow is now deployed, and I can send some messages to the flow using curl. To do that, I need to get the host name from the location field for the pod. So if I click on networking and then routes, I can copy this location to send the curl request to. So if I copy that to the clipboard, I'll now send a curl request to the flow. So it'll be a post request, and I'll just paste the host name. I need to provide the suffix, which is the flow, and now I need to specify the data that's going to be sent to the flow, which I've taken from the tutorial instructions. So I've sent the request and the response has been returned. I'll just send a few more requests. I've sent one, I'll send another 4. That's 2, 3, 4, not one more, 5. So I've sent 5 requests into the flow. So now I should be able to see some data in Instana. So if I open the Instana backend web UI, I can go to Analytics, and I can access the data by selecting a filter. So I'm going to specify the endpoint name, select contains, and I'm going to specify, in this case, request flow. So it's found the request flow, and if I select it, I can see the spans. So there are 11 subcalls, and I can select colorize by endpoint to see the individual endpoints, so it's easier to see. So if I select this first one, this is the endpoint where it received the HTTP request, and you can see the data that it's sent to Instana. This one underneath is where it puts data to a store.queue. And underneath is a graphic which shows the call hierarchy. So I can drill down and see the different calls that are made between App Connect Enterprise and MQ. I can click on the store.queue and click on Analyze Calls. And here I can see the calls that were made. So I can drill down and click on each individual call and see information about the endpoint. This page here shows me a summary for all the calls that were made. I can click on endpoints and view the endpoints, and I can see the calls. So this allows you to observe how your software is behaving in your integration solution. So in this video, I've shown how to use IBM App Connect Enterprise and IBM Instana to observe the transactions that occurred as messages passed through message flows I enabled OpenTelemetry on the integration runtime in the container for the App Connect Enterprise operator. After sending in messages, I was able to observe metrics using IBM Instana.